Before I get into it, I wanted to just give you guys a little bit of background because I don't know how many of you are in the oil industry or not, so before I start using some terms, I want to make sure I get a good base for everybody. The video that was shown about the Shell Prelude, that's actually a good introduction to give you an idea about offshore facilities. Now, that one is an engineering marvel. It's one of the largest. In the I/O count, as far as number of instruments, if I counted, it was almost like 13,000 instruments that were on that facility. So one of the biggest challenges for us for deep water offshore facilities is the integration of the Subsea master control station and the topside DCS. So when I say MCS, that's the brains, the heart and soul of the Subsea control system. So in deep water applications, you will see a huge, in the subsea industry, you'll have the whole infrastructure that's underwater. So you'll have all your production wells sitting perhaps 60, 70 miles away from the facilities with that infrastructure sitting there. And there will be controllers, what you call subsea control modules sitting on each one of them. And you have to integrate that into topsides. Now, if you are the topsides integrator, you saw Prelude. So you have 13,000, or say the average is about 4,000, 5,000 I/O points for offshore facilities. That's a significant effort for the topsides facility, whoever is doing the contract for doing the safety system, the process control. So that's a lot of work. And then on top of it, you have a lot of OEM packages that you have to integrate. You have a compressor, you have an emergency generator, you have instrument air. So each one of these packages, they have their own controllers that you have to integrate. So on average, you have tens of these packages that you have to integrate, and one of them is Subsea. So lots of these packages are perhaps a couple of hundred points. And unfortunately, when Subsea industry was taking off from the mid-90s to the 2000s, a lot of people on topsides did not give that Subsea interface the respect it deserves. Number one, I said, oh, it's just another interface. Let's do Modbus or OPC-UA. Just give me the data. What they didn't realize when they missed was that this is not another interface. If you have a compressor package, that compressor OEM typically is going to have a standard product and everything. So within a couple of months, they may have the data tables for you. So you can plan for it, and they're probably going to read 100, 150 points. On a Subsea system, if you go above 8, 9 wells, each well is probably average of 800 points that you have to read back up, okay? And as we go into some of the models, I'll show you why there's so many points that you have to read. But again, so that was a very challenging integration. And a big part of it also is the timeline, because you have your topside folks are working on the topside scope, and then you have the Subsea folks are working on their scope, and they're not going to give it to you until the end. So that's usually, you're close to doing some in-house FATs on your topside system, and then maybe the Subsea system will be ready, and then it's given to you. And to try to integrate that many points, a lot of time it resulted in like major setbacks to the projects from schedules and things and commercial impact. I still remember one time we had a project, and okay, so at W Industries, we're system integrators, and we've had the opportunity to be on both sides, doing the top sides and also doing the Subsea for one of the major Subsea equipment vendors in the world. And in one of the meetings, I had the top project manager who's managing $2 billion or so. He said, I need to talk to you. He said, look, I don't care about your commercial proposal. I want you to add 20% to it, but I want to make sure that I have no headaches, because from my experience, that interface is always a problem. So I want you to add resources to make sure this doesn't happen. That's never happened to me before. Somebody says, mark up your price 20%. I just don't want headaches, because to him it was a small piece, that control system, but it always seemed to cause some problems. And I think, like I said, it has nothing to do with, it's just the nature of the beast. You got two systems being developed in parallel, and then you have to integrate at the end. So what that did is basically in 2010, everybody started realizing, from operators, subsea equipment vendors, DCS vendors, integrators, that we need to do better. We keep doing this every time, and it's just difficult. We got to do something better. So it was a JIP established called MDIS, which is MCS to DCS interface standardization. And the objective of our group was to basically streamline that interface. So the first step for us was what protocol should we use? Okay? And we listed all our requirements. What do we expect from a new protocol? Historically, the default was Modbus OPC-UA. So we looked over all the top major industrial protocols, and we did an evaluation. We started with 10 and went down to 3, which was Ethernet IP, Profinet, and OPC-UA. Those were the last 3, which we basically, after that, we hired a consulting firm to do some testing and to evaluate all these products, all these protocols to our requirements to see where they stand. And at the end of it, we basically, the group decided to use OPC-UA. So that was just the beginning of it. Now you have a protocol. But that's not enough. If you tell everybody to use OPC-UA, without a good companion spec, you're not going to be able to, it's going to still be a disaster, because it's just a protocol. So it's very important to have that companion specification and to have the information models defined. What you see here is basically the couple of architectures that it supports within MDIS. We have case 1 and case 2. I'm not going to spend too much time on it, but so again, you have typically your DCS system, you have your subsea control system, and you have to exchange the data. Case 2 is a typical. This is where MDIS comes in, which is basically the communication protocol between the MCS, Master Control Station, and the DCS. Now we support another architecture, which is where basically in the case where the MCS hardware is similar to your DCS hardware. Let's say it's Yokogawa or Siemens or Rockwell solution is used for the top sides, then the MCS brand is the same. Then in that case, then they'll communicate natively. However, to interface with the subsea gateway, then they will use the MDIS protocol. Slight differences. Here, you have a lot of handshaking that has to happen between the MCS and the DCS that has to be handled here. In this case, this is called the integrated solution, where the MCS is the same brand. Here, this is more just data exchange, and because since all the handshaking is between the MCS and the other DCS hardware. Another thing in the companion spec is basically defining MDIS objects. So there's a list of objects that we define, all the way from subsea valve, choke valve, instruments, flow meters, just random digital instruments, fault and warning, processing, interlocks, defeatable interlocks. This is basically has to do with the handshake between the two systems. The one I show in this picture here is basically you see so on a topside valve, if you're working on topside in a plant or something, what you see on a valve, typically you have a solenoid, if you want to energize it or de-energize it, and you have some limit switches to figure out if it moved or not, in what position. In subsea technology, we don't do that. We don't have limit switches. You have multiple solenoids within a subsea control module. So to figure out the position of a valve subsea, we look for 4 things. Number 1 is, what was the last command received and acknowledged by the subsea control module? Okay. Next thing is we look at the pressure on the hydraulic function line that's designated for that actuator. Did that pressure build up or not? Did it build up above a certain configured point to move that actuator or not? And then we look for the flow. How many liters did hydraulic fluid did we flow after we sent that command? And the last thing we look for is a profile of that valve movement to make sure that the valve didn't get stuck or something like that. So you have all that data points associated with one subsea valve compared to a topside valve where you have a solenoid and a couple of limit switches. So it gives you an idea for the amount of data. So you got the So it's like a typical control for your valve, and it shows the pressure on it. This is a bunch of configuration data. These are some interlock conditions with that valve, open, close, some defeatable, some are not defeatable depending on your access level. So all that stuff gets built into the object and information model. So that's one object. So once you do that, so this is what a subsea Christmas tree looks like. On the right over here. This is basically, it's a big structure of steel pipes and then a lot of valves, actuators, and sensors. And that's what it looks like. So this is number of valves that you have on a subsea well. And you have a number of subsea sensors that are on the tree. Some of them are downhole, and some of your hydraulic utility type pressures. So so this basically gives you an example of the aggregation. So each one of these is an object defined with an MDIS, and then you can, within the OPC-UA, you can aggregate a lot of these objects into one full object that represents this tree. So some of the other things that in the companion spec that helps is, which has been a great feature within OPC-UA, is how we exchange this configuration. Remember at the beginning I told you one of our biggest challenges is this small time. Once the subsea equipment vendor is done with their development, and they say we're done, and okay, here's your data tables and everything, the topside folks it's going to take them a while to get everything updated, and it's a very tedious process. We're here, we basically, it's defined in MDIS as basically needs to be it's a node set file, it's an XML file that gets generated by the server and gets given to the client app, to the developer of the client, and the data gets imported directly, and it basically streamlines this development on the client side as well. So in addition, we have also some validation and certifications, and I'd like Paul to come back and talk to you guys about this.